All right, I think we're just about ready to get started here. It's almost 1:30. Hello, my name is Scott Friend. I'm the president of CFTA, and I would like to welcome everyone to this month's webinar on going from zero or 0, to intelligent geospatial inventories at the University of Colorado Boulder with Ilene MacDonald from the University of Boulder, Colorado, and Colin Hobson from Open Spatial Corporation. How about if I turn it over to you, Ilene, and you can give a little bit of background on yourself, and maybe Colin, you could also give some background. Go ahead, Ilene.
Okay, hello everybody, and thank you for joining us. I'm really happy to do this again. Um, I've been with the University of Colorado for 14 years, the GIS specialist, and basically in the very beginning single-handedly brought GIS to the University of Colorado Facilities Management, and of course eventually develop and implement the GIS. Looking forward to sharing that with you guys today. Colin?
Hi, good. Yeah, hi, this is Colin Hobson. I'm with Open Spatial Corporation and University of Colorado at Boulder are using our solution. So my background is GIS for close on 20 years now, and pretty much focused on the engineering CAD divide, and I manage the North American office of our company. Right, Eileen, I think you can go ahead.
And you're going to do next slide?
Yeah, so just the agenda for this presentation. So this is a presentation that was presented at the CFTA conference in San Antonio earlier this year. For the agenda, we'll give some background to the data and the situation, as well as the system selected. Talk about project phases and moving through those and all of the steps and issues and deliverables for why we're doing this and what did it deliver to the campus, and then look at next steps. So I'm going to hand it over to Eileen because she was there at the beginning and I only joined a little bit into that. So here we go.
Next. So just up front, I just want to say that I'm going to use the word Munsys several times, and that is the company name that Colin used to begin with. They've since gone through a name change to Open Spatial. You know, I'm using both names throughout the presentation. So to get started, I just want to say that the biggest problem that came to light in 2004 was the fact that our base map was on a Cartesian grid, which meant that 0, was based on the intersection of two streets there, and the majority of the campus was in the negative quadrants of the Cartesian grid. And there was no true locational system to the map whatsoever. And the process that we used to update this base map was that we would receive accurate consultant submittals like roads, buildings, sidewalks, utilities, and such, and then we'd copy the area we needed off of that 0 scale. And Colin, go back just a second. I think go there. But anyway, we'd copy the pieces we needed off of the consultant submittals, and then we'd scale it, twist it, nudge it, stretch it, whatever we had to do to get it into this Cartesian grid. And therefore, none of the site information was accurate whatsoever, or was the utility information. So this went on for years and years. It was simply ridiculous. Didn't make any sense. So I took the map, this particular map in Cartesian grid, to the university professor that I had in 2000, well, before 2004 anyway, and asked her what we needed to do to get this crazy map on a real coordinate system. And the phrase that she used that I liked so much was, after looking at all the problems we had, she said it was unsystematically in error. And I remember that phrase forever and ever because it really described the mess that we had. So what we tried to do next is simply correct everything. And you can go to the next slide now, Colin. And what we did was, with a very little bit of money, we were able to build a control network for the university. And this was based on existing monuments and benchmarks that were already in place. We didn't add anything new. And the next sheet shows the different information about the lat long and coordinates of each of the benchmarks. Go ahead, Colin. So right there is just a very small sampling of the multiple monuments and benchmarks on campus. And again, they were already existent. So this is where we began to shift that 0 point to one known location in the monument map, which was at the intersection of those two streets. So next, Colin, became the map cleanup. And what we tried to do here was use a variety of existing campus resources, as well as City of Boulder and Boulder County information and campus archives, and just really tried to make everything locationally correct. Everything on the site that is how we began, and then after we got that corrected, we moved on to underground utilities. So basically the beginning here was using these various resources to upgrade what we see above ground. And then next, once we had our site maps, like every road, every sidewalk, every building polygon, we started a pilot project. And the pilot project, we took a small area on East Campus that was doable instead of the whole main campus, which had so much information. So we took this small area and we began GPSing above ground utility with light poles. And that gave us a way to set up our data dictionary in the GPS and look at the kind of attributes we wanted to collect and to check the location of what we had on the maps and what, because we shifted it from the the Cartesian to the coordinate map. So it was a real good test area. And the next slide shows another area of campus where we began GPSing a majority of other utilities like water, sewer, drainage. And you can go to the next one there. So you can see how it got pretty convoluted there with all the different pipes and nodes and manholes, fire hydrants, water valves, catch basins, and so on and so forth. We began just correcting this on the AutoCAD map. We did not have a GIS at this point. And then what we began to do after putting together utilities is started to make a case for a bona fide GIS, and we started to make presentations for months. Next slide, I think Colin shows where we started. We had to put together some decision factors. And one of the things we really wanted to focus on, given the fact that we had that beginning 0 problem, and what I had said before is that this is where I realized I had another 0 problem, and that was no money and no staff to help put this together. So the way to go about that was to begin to build, do some research, figure out what was going to work for us. And the basic things were AutoCAD and Oracle. This is what we already owned, and which didn't cost me any money up front to go out and buy a new platform like ESRI or anything else. So we just started with what we had. We wanted something that was out of the box functionality so we could customize some of our GISs. We had to get, a big part was to get IT department approval. And this was important because we were going to collaborate with them to get this up and running eventually for other people to see. So that was an incredibly important piece when you're building a GIS. And one of the big things I did was do demonstrations for various departments, as well as have Colin come in from Open Spatial and do demonstrations to staff and work groups. And then another big great help was people and staff at MSU. I had several people there do go-to meetings with me, and it would help me set up the database. In fact, I called the guys at MSU my big brother because they were so helpful in helping me get started, and they were also using the Munsys products. So the next step was, after doing some demonstrations there, was to get buy-in from management and administration. And the things here, I'll just go through a couple of them, is the demonstrations to administrative, some of the different departments, was to help them recognize the need for a change. And part of the process here was to go to them with a detailed outline and implementation plan that showed things like cost and timetables and who the responsible parties would be, and what it was actually going to take, what the vision and the mission of putting together a GIS was going to take. Another thing was when Colin came on board and was able to actually show how Munsys worked and how it would work for our department and the pros and cons there. And a big part, again, was just allow time for question and answers for everybody. It seemed, you know, as I say there, that we ended a lot of these meetings with more questions than answers. And the benefit there was for me to go back and research that with the help of Colin at Munsys or Jade at MSU, and try to get to figure out what was going to work best for us based on other people already having been through it. And then lastly was the follow-through, just to stay organized and do what you promised. I think keeping management and department heads in the loop was extremely important. I put together a GIS steering committee, and that was a place to go to ask for directions and prioritize our needs, and also to provide a periodic progress report so that people had some information there. So, and once they said yes, we got some money to move forward with Munsys, and that's when Colin came on board, and he's going to talk a little bit about the project planning in that regard. Once we go ahead, Colin.
Yeah, thanks, Ilene. So the project planning was, where I came in, it was multiple departments and really clarifying, and I'm not going to go into the details of these, but just what were the decisions we're trying to solve or support in terms of business drivers, and then who were the different people and what exactly did they want. And we then split that into phases, and we'll talk about that in a minute for phase 1, 2, and 3. And then all of the data and dealing with the data in terms of loading it, as well as specific applications for, targeted tasks or groups within the campus. And so the phases, I'll just give a quick high level on that, and then we'll actually look at some of the details. But phase 1 was just looking at existing data, taking the work from the pilot project, taking all of that and consolidating data from many different sources into one single geospatial database. And once, that was a large task, and we'll spend most of this time talking about that. The other goal was at phase 2, once we had data in the system, we wanted people to be able to see that information such that they could do continued cleanup and view it and start getting feedback and getting people involved so that they could be referring to an online map rather than coming into the facilities group and saying, can I get a base map of a given set of information? So once that was in place, then we could move forward, although there were a couple of issues in there in that people actually prefer using paper to do the markups, and usually there's an intensity of information that comes online when comes onto a piece of paper when somebody goes through them. And we'll show some of that in a minute. Phase 3 was taking the data. So after phases 1 and 2, you should now have a good base set of information that's available to different people and users. And phase 3 is then to tie that in with other systems like document management and work orders, and then build out that data set such that people can use the map as another way to find information about any given asset and build from there. So let's look at phase 1. Specifically, this is the data gathering phase. And, Ilene, maybe you want to talk to this one?
Sure. So when we went through for phase 1, we were able to purchase a variety of projects right up front just to get us launched and get started. And the biggest part was the Munsys application that helped us do the editing. We were able to edit everything within AutoCAD using knowledge and years of experience with AutoCAD to edit directly in Munsys. We had a management console that took care of the developing of the data tables and such. And just the whole process there, you can read it on the left there, and then just working to continue to add new data sets time and again, like the building polygons, the building text, pipes and nodes, and so on and so forth. And as I said earlier, we began GPSing, so that became another data set and another table. But, And as Colin just put up there, these are just a very few of the layers. I think we were layers, which means a data table for the various objects on campus, from buildings and roads and nodes and.
Hmm. And so, what we would do is literally work layer by layer and go in and update that information. So, to just illustrate that, when the slide comes up, you'll see, common data conversion challenges where you've got line work that isn't actually snapped, so you really could not build out a connected set of pipes out of, say, these steam pipes here. Also, you'd notice that there's text in the middle of lines, and so this is common. This is standard CAD procedures. In some cases, the line would be continuous. In other cases, line work would not break it at nodes, and you'd get incomplete stuff without endpoints. And so the Munsys tools were used to really build out a connected network. In the case of the utilities, it's different for different data sets. If you're doing ground panels for the softscape, then you're going to be drawing polygons, and all lines need to start and end at some kind of node or symbol. The bigger problem with CAD drawings is often that the text is just text, and the attributes stored within that text is what you really want on the object itself, such that the information is separate from the graphic, but linked to it. So the graphic is something you can view, but you can query the information. And so what we do then is go from this CAD data into a system where you could see the same information. It looks the same, it feels the same, and in fact you're using the same CAD tools. However, you've got a set of attributes. So what you're seeing there now is data that is in a single central database and has columns of information that go with it that you can then see. So, for example, if you looked at these items here, I've just highlighted a couple on the screen there. Say the tree, there's the type of tree, the diameter at dBH at breast height, the spread, the height, the condition, that sort of stuff. So now you've got useful information that's there on your data set. And so you can see that. Also, you have tools for getting the editing such that you can be consistent with diameters and types and materials, and use pick lists and drop downs such that you build out a consistent data set and complete data set. And actually I can switch over to a live demonstration of that just to kind of give you an idea of how that looks and how it works. I think there's a delay in the slides. You should see a AutoCAD window come up shortly. And the first thing I'm going to do is actually log into the system, because this is now, while it's in AutoCAD, we are actually logging into a database. And each user would have a username and password and have different permissions as to what they could edit and etc. So this is campus here. A campus for Boulder is an integral part of the city. So there's different parts of campus. So east is over there and different areas. But the line work that you see now is out of the central database and attributed. So now I'm actually live on the system, and we can go in and query those two items that I highlighted. So anything on the screen, you can click on it and show information about it. So you'll see that one of the things we did was to verify that objects are in fact existing, because just because you had it on a CAD drawing or on an as-built doesn't mean that it's a guarantee it's actually out there. And what you want to do is, if somebody's out there and sees something, we want to actually then get that back into the system, that it does in fact exist, and at least we know somebody's looked at it. And then ID numbers and attributes of any of the information. So if I click on pipes, for example, you can get information about that, or natural gas lines, or these purple color is tunnels. And so you have that information in the system. And so that's, essentially now what you have is a database that you can create a drawing of any color, shapes, and do queries against, of, find everything greater than, larger than, or within a distance of, and pop that on the screen, and then use that directly in AutoCAD. So let's go back to the slides. And so these are the tools, by the way, that you would use. So if you were in doing stormwater, there are tools there for putting in all of the storm stuff and doing all of the editing right off the menu. And so those are productivity tools to be able to build out your data sets in an intelligent way, and having those off the shelf really made a pretty big difference to getting UCB to go from the CAD data into that. Also, as I'm on the screen here, I'll show you that you'll notice that we are, if you look down at the bottom, we're in real world coordinates here. This is the state plane coordinate system, and so everything is located, and you can pop it up with maps, etc. behind it. And so you can turn that on and off and get your imagery, etc. Within the system. All right, let's go back to the slides and keep going from there.
Colin, I just wanted to. I wanted to say also, without Munsys and the out-of-the-box tools to edit and correct the drawings, there's no way we could have moved as fast forward as we did during that time of cleanup, because we were able to use AutoCAD blocks for our symbols, and everything you saw just now is part of the application and what we use to clean up. And the queries, such as querying all the 12-inch pipes, or querying pipes that don't have a diameter, and we were able to see throughout campus exactly which pipes needed that information. We could turn around and send that to one of the field guys who had information, or check their books that they carried in their trucks, and we were able to update the data set that went with every single object for the most part. If we didn't have it, we go by the rule that no data is better than bad data, so we'd leave it alone. And then that object verify field, we would update that from it was existing on the map till it was field verified, or it was as-built, put in there by an as-built, and so on and so forth. Tools that come with the different modules, water, sewer, and drainage, and Munsys, is what allowed us to move fast and forward.
Yeah, and on the screen at the moment I have some of those queries, and you can see there's stuff like queries for cleanup, or for this particular user, you've got, where value is null, so you want to go and calculate if, in other words, you had no ID for that particular item, and things like that, or abandoned, or all of those things, so that you can just run through and look at duplicate pipe condition. Any of that sort of stuff is just data cleanup, making sure that you don't have duplicates, that you have everything numbered, ID'd, snapped, and attributed. So a richness of tools there. Okay,
Exactly.
a good point, Ilene. I guess I just take that stuff for granted, but anyway. Okay, so that was phase one in general. We're going to come back to there's a connection between phase 1 and 2, because what the idea was phase 2 we would have a web-based tool, which we did, and we'd have a number of people using that. They each have a login. You've got about 88 or so logins were at that time, 130 odd layers, and any number of objects. That keeps growing. And so just to look at that system, and I'll come back to tie those two together, but basically anybody with a browser could look at the same data that I was just looking at in AutoCAD. You can look at the very same information in the browser, and then zoom in on that and get tooltips and switch layers on and off, which you can see on the left. And then click on anything and get the same information that we were getting in AutoCAD. You can see the attributes, information panels, and if we move on from there, you should get a slide coming up now with ground panels. So this is the kind of gardens usage. Is it turf? Is it shrubs, flowers, or aggregate, or whatever? And then obviously also linking in things like photos on signage, things like that. But the big problem we had with going from phase 1 to 2 was there was still the big challenge of there was a knowledge of information in many people's head that were operational out there that was still not in the system, because all we've done at this point is put into the system what we had in the documents. And so we actually then came up with phase 2.2. And so 2.2 was where we decided actually to revert back and do a combination of old school and new. And so what Ilene did was literally create a set of source utility books, one for each of the, I don't know, what it was like 14 utilities with 47 pages each, and give that to whoever was responsible. This is an example of the electric one, sheet by sheet, for them to go and mark it up on the piece of paper so that we then had a set of information. So that was the title block, and here's an example of one that was returned. So once the slide comes up, you'll see a lot of redlining and questions and queries. So Ilene, do you want to talk to that?
Well, this was phenomenal when we saw this page come back, and this, what you're looking at right now, is just a portion of one page in the utility, electric utility. And this was staff and some students doing not only archive research but in the field notes. So a lot of these guys had multiple and various books in their trucks. You took that information onto this editable electric book, and again with water, sewer, drainage, steam, all the others. And this is the kind of detail we would get back. It's just phenomenal, the amount of knowledge that was out there that had yet to come into the CAD office to put it, and then we could take this, and as you can see in some of the areas, maybe right down on bottom left where it says center, you can kind of say center. Right below that is a red archive number that shows what archive they pulled that information from. A lot of it is just in the field notes as well, but this is what we would take, and note by note by note we would add it to the database. We added several columns to the database called archive number, and we would enter that number 231-2-612 or whatever it says, and then that way when you pull up that piece of electrical cable and you click on it, you'll see the Munsys database record show you that there's an archive that goes with that. Eventually the goal is to get to where we can click on that archive number and bring up the archive. That'll be in a phase 3 later down the road. But it was one way to say, put away your books and let's get all of this into one silo, the open space. In fact, one of our staff when we were working on this, his comment was the 80s called and they want their paper maps back. And we thought that was a way to get everybody on board and try to get this information in one silo. Go ahead, Colin.
And so this was a long procedure, and you know, actually stretched out over probably about a year or so, and pretty intense. And this data set, actually we've actually scanned those pages again and put that as a raster backdrop behind the current map. So you could even come back and still refer to this markup even, because it's yet another data point of what somebody interpreted as being in the case, and you can kind of compare what the reality is. But so that was the combination of phase 1 and 2. We had to kind of go back old school and get to that and work through that. And I think you have just what I think was 1 or 2 map books that are still outstanding at this stage, something like that.
Yeah, I believe the sewer book is still out, and with all the catch basins and so on, they're still working on that, staff either. So you're gonna, I mean, this is one of the things we talk about again is time management. You're not going to get everything back the way you had planned exactly. So you've got to have room to adjust what's happening.
So I'm going to move on then to the kind of deliverables. Why was this done? And so here's kind of a list of the kind of reports, inventory, and maintenance stuff. Ilene, did you want to talk to the ground panels and signs, and I'll do trees?
Sure, I'll pick ground panels and even signs or West Nile. So for the ground panels, this was something that MSU was doing, and we were able to get their help to set up our system as well and our tables. And what was really important here is that the state requires a turf reduction planning for the campus just to do some more zero-scaping. And by getting the area totals for the ground panels, such as how much turf, gravel, and such, we were able to turn around and give those totals to the grounds maintenance department, and then they could make their adjustments with purchasing. The planning department took a big step in inventorying all the signs on campus, because we were doing some rebranding with the CU logo, and so signs had to be changed. So they got a little bit of money and sent out students to go and photograph every sign on every building, every freestanding sign, the wayfinding signs, and we were able to get all those photographs in there. And I think when we were showing you flex maps, you could see that there was one photograph. We showed a photograph of one of the signs on the building. So that was really important to see where updates needed to go. And then for the production of those signs, how many signs with the left arrow needed to be printed and so on and so forth. So it was a real good solid inventory of the signs. And West Nile, I'll just touch on real quickly. The state and the county require reporting for the West Nile virus out. And this was a way to GPS ponds and get our area totals better for the ponds using the GPS, and then the information about that pond and where West Nile was found. Really helped them with their totals and report. Neil Hubner, our other staff, was working on trees with the grounds department, and Colin will talk with that because more recently they've put together data regarding this. Go ahead.
Yeah, so the trees are essentially doing a handheld rangefinder and recording trees to get the height, and then also entering the species. And that was just a data capture exercise, but it's been modified fairly recently to prioritize the ash trees because of the emerald ash beetle borer. And trying to identify on campus where those are, how many of them there are, etc. And in fact, if I go back here, I can get that out of the way. But in essence, you can see these are GPS trees here, and if you go click on any of them, you get information on these trees. And so what we could do then is literally, just use the GIS capabilities and go in and pull up trees for where there were ash trees. So I've set up a query here for running ash trees and put that on the screen. And if I actually just put the line weight on, you'll see the red ones. So here's an ash tree. And if you click on that, you'll see information that's recorded about it. So this is a 38-foot tall ash tree. It's in good condition. It's actually a memorial, and it's part of the funding, and is a general fund, and it has an ID. And so you're starting to track the genus and species, and have then an inventory of how many and what they are. In fact, Neil recently put together a map. Here's an example of a sheet plotting out the different kinds and owners of the trees and where they are on campus. And so the other issue is obviously there's ash trees in the city that we need to track too, but just to get a handle on it, I think there's some 500 and something ash trees at the moment that we have in the data set. But that ability to start now using this information for reporting and that sort of stuff is useful. It was very useful in the data checking and data cleanup. So Ilene mentioned we had this column object verify. Here's water nodes report done, I don't know, sometime, and it just shows that we flagged some as existing, what kind of water node. The generated means we've added in pretty much a fitting for a junction here just to create the connected network. And so you can get a listing out of, of the data sets right there. So that the ash tree is just, in terms of examples of what is the business problem we're trying to solve, ash trees was just an example there. The tunnels, you'll notice on the map there, I'll show you some more in a minute, but tracking the underground tunnels, access points, and then starting to deal with that in sections was one. Ilene, I think you did the insurance underwriting. You want to talk to that?
Yes. Again, with the querying of the data in the database, we have to report every year for asset inventory and insurance of those utilities under campus. So the next slide shows an example report that we send to the insurance underwriter, and again it's just a simple tally of what's out there, and they didn't want the number of fire hydrants and light poles and such. They basically wanted some underground information, which is the linear feet or miles of, you'd see it's just a very simple report, but it took a couple hours to go through what it is they wanted, how to put it together. And now, in the beginning, it took a couple hours. And with Colin's help and the querying the data, we were able to pull out this information. And then I would do a conversion files and submit this. And the amount of information that changed from what it used to be from guessing or doing a query in AutoCAD back in the early 2000s to what it is now, it's as accurate as I have, in the database. It's really helped them out.
Okay, lessons learned.
So just real quick, I'll go over this real quick. I think what I had said before is that we didn't really put together our mission statement up front. And although I had a vision, my mistake was I didn't share it a lot with, I knew what I wanted, I knew what GIS could do, but I didn't take the time to share it except when I started to do demonstrations. And then I realized how important that became, that I wish I had spent a little bit more time on this. So that's my advice. Figure out what business problems you're trying to solve, what your priorities are, and write it down. And basically, if I went back to the mission, it would simply be to provide, accurate site and utility information, both above and underground, and get it to people in an easily accessible manner. Secondly, I think every GIS project needs a champion, and for many, many years I was that champion, and with the help of the consultant and friends at MSU, I was able to put forth new ideas and get that going, and it became, I became the point person to where people would ask me what's next, and then I would take those questions to the steering committee and then ask those who had the money and the power, what direction should we go? Where do you guys see the needs? What's out there that I haven't thought of? And so on and so forth. I already spoke about the time commitment. You really got to think about that. Like we just said, after 2.5 years, the sewer book still isn't back with all of its edits. And it's based on who's got the book and what they can do. Fourth, I think a real difficult part is staying on schedule. It's so important to do what you said you were going to do what you promised, and try to stay on schedule as best as possible. And that means even more meetings and more work priorities that some have to be dropped while you move on to others. And then last, expect the unexpected, like the sewer book not coming in, and so many other computer server problems, and so on and so forth. So I'll let Colin speak real quick to where we are today, since he's more plugged into.
Sure. And so we have, we had phases 1, 2, and 3, and we've chatted about phases 1 and 2 in some detail. Data integration, this is tying the asset inventory above and below ground to the other systems, like the document management system and the work order system. And that's moving to the Open Spatial Enlightened product that has that pretty much that framework built in, and so that's there. Also doing a pilot of that, so same thing, do a pilot and then refine it from there. Other options are like mobile GIS, laptops, tablets, and just getting people to now be engaged in using the data themselves, and getting as many people to be doing the updating as well, such that it's not a bottleneck challenge. And also finding the staff to do that. And so what you're doing now is you've captured your base information, and then you start using that in a more intelligent way. And so things like this, being able to get area analysis on the fly on top of your maps, being able to drill down into multiple databases and get the information, and then have that linked to documents where if you click on the link, now you can go in and open up that particular document. And also, just one thing that's, sorry, Ilene, do you have to add to that? Okay. And then another thing that's come up, and this was, at the CFTA conference, there was a lot of emphasis on 3D as well. And so that's also in the future here. Well, actually, it's here right now, because there are products where you can link to this very same base information. You can link in 3D, and so I just tied in the aerial photo that we were using, as well as the building outlines and the CAD data that I was showing you inside of AutoCAD, and pulled that right into this is the Autodesk InfraWorks product, but pulled that information in, and now you're doing a live connection to that information. So once again, this is just yet another use for this information. So if we zoom in 3D, and I'm showing you screenshots of it because there's quite a lag in performance for the presentation, but at the conference we actually did this live. And so if you look carefully on this map, you'll actually see the assets. There's the same manhole that I clicked on in CAD, and there's the tree. And if you then go a little further, you can get information on those. So here's the same tree that I clicked on. And then from there, you can also use this tool to start looking at the underground utilities in the 3D environment. So if we back off the opacity of the surface image, you should now start seeing the pipes and utilities under the ground in situ, and now you get a useful picture. And I mentioned tunnels earlier. The little gray lines that are sort of square cornered, those are the tunnels as well, and those became fairly important, useful information. And so with this, you can then grab your mouse and look from underground perspective, look through the top. You can do shadow analysis, any of the sort of 3D stuff. So here's going underground, and there's the same manhole and tree that we were looking at. So now you can see the tunnels in there, and you can see the looking through from the bottom of the ground, you could see the same data. Now once again, this is from the same information that we were editing and updating inside of the Munsys product in AutoCAD, and now we're visualizing the information. So the pipe diameters are being read and live out of the database, for example, and are used here in this perspective. So a thicker, thinner pipe is part of it. In addition to that, if you go back up to the top, above ground, you can take Revit models and put them into that same 3D model. So when you get there, when you get the image in front of you, you'll see a building that has sort of white aspects, and that's a Revit model superimposed on the building outline. Now, the original building outlines here have simply, you'll see they all look the same, and they have the same roofing, which, UCB have done a great job. Their campus is very consistent look and feel. But in this particular 3D model, we haven't taken the time to go in and put the real, the real materials for the outside of the building and the roof, and that can be done. But essentially what you're looking at is a 3D model that I put together maybe in 2 hours, just based on linking live to the original data. So here's a Revit model located, and it wasn't the Revit model. By the way, if you are making Revit models, please take the trouble to actually get them, get the reference, coordinate reference points actually set up, because then it will come in place, because I sort of had to drag this one and just shift it inside the 3D tool here to where it is. But you can see underground through the opacity. This is the foundation structures below, and then if you zoom right into that, I mean, like you can, it's nice in a live situation because you can see the mouse. But I'm going to switch the slide where you've zoomed right inside of the Revit model, and you can actually then get to the structural components within that model and zoom around and even look through the window and see what the vista would be, etc. Now, from a layout perspective, obviously we have the utilities coming into the building, so you can see connection points, etc. But just to add that 3D perspective. So that's pretty much going from 0 warping data to fit a arbitrary system to attributed, connected information, including the ability to also then move that into other environments like 3D and then drill down into other systems. So in summary, that's pretty much the pathway that UCB have walked, and that's our presentation. So thank you very much, and we can open that to questions. If you do have a question, you can type it in there. Oh, I see one there.
Looks like
Yeah, sorry, there's a question. How are we storing the photos in Munsys? So those photos, while you can store photos as blobs inside of Oracle, because Munsys references Oracle as the data source, where those were not, they were simply stored in a folder and linked to. So on each object, you basically store the, you have a link with a photo name to, which stores the path to where it is. So a shared folder would be the answer to that. So just on a network location, so anybody can get to it from there. And that's also usable in the browser. All right, any other questions? Okay, I'm leaving the floor open for questions there. Ilene, did you want to add anything at this time?
No, not at this time. I think it's just important to have staff and have a vision and just start where you're at. Get the help from the NCFM TC conference, and there's so many people and resources out there to help you go from any stage. Like I said, MSU was my big brother in a lot of this development, and then the help I had with Colin was just tremendous. And we've been able to move every year. We seem to be moving a little bit faster than the year before because the data has built upon itself time and time. Incredible resource. And like I said earlier, we've got one silo with all this information. It's not in, the only information about that utility is in somebody's truck out in the field, or a map set that's maybe 10 years old instead of yesterday. In fact, with Flex Maps, when Colin was showing the different tooltips and the info palette and such, that Flex Maps, as we set it up, it's instantaneous. If we made an as-built set of utilities into the database in the morning, people are looking at it in the afternoon. I mean, within minutes, as long as I post it and then they log on to Flex Maps, they're seeing it right away. So it's a instant viewing of what we've got going there. There's just so much availability here, and it's not, it's affordable, it's not clunky or slow, and all the AutoCAD tools that we already know are usable, as well as that's what we are, an AutoCAD shop. We get submittals in AutoCAD, and that's what we wanted to use. We didn't want to have to change a submitted drawing into an ESRI drawing, even though Munsys has that capability all worked out as well. If that's what maybe Colin can speak to that too.
Yeah, I don't want to push product too much. Anybody could be, contact us. Openspatial.com is probably the best place to go. Anyways, good. Any further questions?
Looks like you have one from Jen. She wanted to know what your staffing number was.
All right. Yeah. Ilene, how many people?
For many years, one. And then about 2 years ago, I was able to hire a full-time GIS technician, Neil Hubner, which is now very integral in running the GIS program. But basically, it's been just the two of us for the last 2 years, and then myself. But I had the help from Munsys, and then we had people that were doing GPS out of other departments that were submitting information. Of course, I pulled downloads from the city of Boulder surrounding campus. It wasn't like I had to do everything myself. I used sources out there. Dr. COG, which is the Denver Regional Council of Governments, we'd get our aerials from them. We wouldn't have to go fly ourselves, and so on. Not much.
I see another one there from Jade about will Munsys support attachments similar to ArcGIS? And so the answer to that is Munsys is the editing tool in the CAD environment, and so it's really tied into what AutoCAD does and how that supports objects there. In addition to that, there's the Enlighten product, which is the web-based interface, and that does allow you to work with a number of different attachments. But I'd be happy to take that offline as well for specific details. All right, looks like we're done on the questions.
Colin, could you address Jade's first questions about linking the photos in Munsys, or did you already hit that?
Yeah, I did that.
Okay.
They're on a network location.
All right, I guess that's it. I would like to thank Ilene and Colin for their presentation on going from 00 to intelligent geospatial inventories at the University of Boulder. The presentation material, the actual presentation is actually already posted on the CFTA website, so you can go up there and pull down a PDF of it. We will also be posting the recording of the presentation for viewing online a little bit later, so watch for our Facebook page and or links on our website for that. I would also like to announce next month's webinar. It'll be on the day in the life of your BIM data. That'll be on November 7th at 1:30 Eastern Standard Time. So look for those announcements on our Facebook page and also on our website. And I'd like to thank everybody for attending, and we look forward to seeing you next month. Thank you.
Thank you,
Colin.
everyone.
Thank you.
Thank you.